Question 1. 0.45 may be written as. What we want to do is to take the two digits after the point, and what we're going to do is to write it as the numerator. So it'd be 45 divided by, and since we have two digits after the point, then we will have two zeros in our denominator. Put one in front. In other words, we have 45 hundredths. The first digit after the point is a 4, so that's 4/10, and the 5 hundredth. And in all, we can say 45 hundredths. That's what we have here. Simplifying this, we want to divide by a number that can enter both 45 and 100. 5 goes into 45 9 times, and 5 goes into 120 times. And so that leaves us with 9/20. The number 3.14063 written correct to 3 decimal places is. Decimal places are basically counted after the decimal point. So what we do is right from the start, we write all of that digits right up to 3 decimal places. The first digit after the decimal point is 1. That's at the first decimal place. The 4, second decimal place. The 3, the 0, the third decimal place. So we write from 3, which is the whole number, and then after the point we count the decimal places. 1, 2, 3. Now, do we actually write 3.140? No. What we do, we basically cut off after the 0 since we want 3 decimal places, but we always check the very first digit that we're cutting off. If it's 5 or more, we're going to add 1 to the digit that is in the required decimal place. So the 0 is in the third decimal place because it says 3 decimal place. And so what we're going to do, we're going to add 1 to the 0 since the next digit is 5 or more. I want to say add 1 to the 0. We're talking about adding this 1 here. All right. Ensure we're looking at the place value. Right. So we're adding 1,000th to the 0,000th. And so we get 1,000th there. And the 4 is actually representing 400th. Put it back there. The 1 is representing 1/10. Add these up, get 1/10. And so, and then 3 to the 0. These are in the ones position, so we get 3 ones. And so this is our solution, 3.141. When writing a number in scientific notation, also called standard form, we want to first identify where the point is. So let's look at this number here, 3076. Where is the point located? If we do not see it, it's actually at the end. Now what we want to do, we want to have this number written as a number between 1 and 10. So it means that we will need to move this point or shift this point between the first two significant figures. So the point is right between 3 and 0. So now that number is 3.076. Number is 3.076. But I cannot put this equal sign here because the original number is 3076, and 3076 is not equal to 3.076. This number is over 3000. This number here is between 1 and 10. The purpose of writing it between 1 and 10 is to write it in standard form that way. Now to get it back to the original number, we need to multiply by a power of 10 that will bring this point, that will shift this point that we have here back to where it was before, after the 6. So how many places to the right do we need to put this point? 3 places back to the right. And so that's where we'll actually have the third power of 10. Every time you multiply by a power of 10, the point is shifted to the right. So we're going to have 1, 2, 3 places to the right, hence positive 3. So this is how we can write this number 3076 in standard form, or it's called scientific notation. It's a number between 1 and 10 times the power of 10. Now here's a trick. If the original number does not start with 0 point something, then the power has to be positive. So right away we know A and B are out because we have negative powers. And of course the point has to move 3 places, and so D is the answer.
All right, so what we have 5a minus 9a minus the quantity negative 2a. How do we simplify this to get one of these answers? Well, it's pretty easy. We just need to look at what we have here. 5 minus 9a is actually negative. That was actually negative 4a. And when we subtract a negative, we get a positive, so positive 2a. All right, another way to look at it, something I learned a long time ago, that if you have a negative that comes before the bracket, a negative precedes the bracket, think of it as negative 1 if you don't have a number if after the negative sign. So we can actually put a 1 there and think of it as negative 1 times negative 2. Negative times negative give you a positive, and 1 times 2 give you 2, hence 2a. Just another way to look at it. Or you can say subtracting a negative give you a positive. Alright, so that gives us negative 4a plus 2a. And simplifying further, again, the signs that we're adding two quantities, and the signs are opposite. We have a positive and we have a negative. So we have a negative, sorry, it's a negative, and we have a positive. And once we have a negative and a positive, the instruction is to subtract. So we subtract 2 from 4, and that gives us 2. So we have 2a, because we're dealing with variables a, right? And which sign do we keep? Well, the 4 is larger than the 2. So now we take the negative sign. If we ignore the signs, the 4 is larger than the 2, and so we take the negative. And so this is the answer, negative 2a. You may stop the video, or I can explain it a little longer in terms of saying 5 minus 9. So if you're on the number line, all right, it should be a straight line there, but don't worry. Let's say we have 5 here, and we subtract 1, we'll actually get 4, correct? If you have 5 take 1, you get 4. What about 5 take away 2? So we subtract another 1. This is 5 subtract 2. That will give us 3, correct? So what if we should subtract 4? 5. Let's see, 5, we take 1, 2, 3, 4, 5, 6, 7, 8, 9. What number is there? So let's look at it. 2, and this will give us 1, 0, negative 1, negative 2, negative 3, negative 4. And so that's how we end up with that 5a minus 9a. So 5, take away 9, let me go to the left, 9 units to the left, actually give us negative 4. So negative 4a plus 2a. And so if we're going to add, so that means we're going to go to the right then, since it's a positive 2. We're adding positive 2, so we're going to go 2 places to the right, and that will give us a negative 2. So that's going to give us a negative 2 here. So that's negative 2a. All right, so we're given that 2x plus 3y equals 18. What is the value of y if x is equal to negative 3? And this one is simple. We can just do it the long way. So we can just say 2x plus 3y equals 18. And let's substitute the value of x into it, which is x equal negative 3. All right, and so we're going to say, okay, this is going to give us negative 6, right? So we're going to transpose the negative 6 over. You don't even have to do another step with that. You know this is going to give us negative 6. So we transpose it, becomes positive 6. So 3y equals 18 plus 6. And then you're going to get what? 3y equals 18 plus 6 is going to be 24. Correct? And so remember, 6 3 is 18. And when you add another 6, that's 6 4 is 24. Now you want to divide both sides by 3. 3 and 3 goes once, and 3 and 3 goes 1, 3 and then 3 and 18 goes, 3 and 24 goes 8 times. So we have y equals 8. All right, so it's very important you know your times table as well. Makes a lot of difference. All right, so we can clearly see that we've been given two equations, and we want to solve them simultaneously. Are we going to solve to get x and the y values? No, the question asks us to find the next step using the substitution method. And if you examine each option carefully, you can clearly see that the first equation was used in making y the subject for a and b, and making x the subject for c and d. So let's see which options are correct. Let's start from D. Let's start from D. Okay, we make x the subject, 7 plus y, and let's look at equation 1. x plus y equals 7. Okay, we can clearly see that they made x the subject, so let's make x the subject, and we're going to transpose the plus y, so x is equal to 7 minus y. Let's look at what we have for d. X equals 7 plus y. So we can clearly see that d will be out, because this is not 7 plus minus y, this is saying 7 plus y, so that's out. Let's look at option C, where x is the subject. Is it 7 minus y? Of course, we want to make note of the fact that x can also be written as minus y plus 7. We can just simply rearrange these two. Remember, the 7 is a plus 7 and the y is a minus y. So we put the minus y first and the plus 7 after. Because remember, we are operating on the same side of the equation, so it doesn't matter if we switch them around, the signs will remain the same. Because remember, it's the left hand side equal the right hand side. If we are moving terms around on the same side, the signs do not change. It's only when you move from one side to the next, like as in the right hand side to the left hand side, or the left hand side to the right hand side. But if you're moving on the same side, the signs remain the same. So this plus 7 is on the right hand side of the equal sign, and it's still on the right hand side of the equal sign. So the sign remains the same. Likewise, the minus y. So if we see any of these options, we know that it will be correct, because they're the same basically. This is minus 7 plus y. We do not have minus 7 plus y, so do we know this is out? Okay, let's see what happens when they make y the subject. All right, so when they actually take the first equation, equation 1, and make y the subject, which is actually correct. Let's see. We have x plus y equals 7. Now remember, this is actually equation 1. And so what we're going to do now, we're going to make y the subject. If we make y the subject, it means that we're going to transpose the what? The plus x to the other side of the equation, from the left hand side to the right hand side. And of course, once you're doing that, the operation change from plus x to a minus x. So let's write that. Y equals, which is plus y, positive y. We don't need to put the plus in front. Equals positive 7, or plus 7 if you want to think of it like that. The plus x goes over as minus x. So what we have here is y equals 7 minus x. Now let's see which one of these agree with it. A is saying y equals 7 plus x, so we know that is out. And of course, we can clearly see that B is the only one remaining, so that has to be the answer. And we can clearly see it's correct in y equals 7 minus x. All right, let's check to see if the substitution was done correctly. So it's in the first equation that we made y the subject, y equals 7 minus x. And we take the second equation, which is going to be equation 2. Let's write equation 2, 2x plus y equal 10. And we're going to replace y with what? With 7 minus x. So we have 2x plus, we're going to replace the y with what? The 7 minus x, because y equals 7 minus x. This is coming from the first equation, but we put it in the second equation, where y is 7 minus x. And you clearly see that was actually done here. All right, if we want to solve, we found our answer. If you want to solve this, then we can say, okay, 2x. When a plus or minus precede the bracket and there's no number there, you can think of 1 is there. So we distribute the 1 by distributive law. So positive 1 times 7 is positive 7. Positive 1 times negative x is negative x equals 10. This is just solving it because we already found our answer. So 2x, let's group according to the x terms. So with 2x, and this is a minus x. Wait a second, why didn't I change the sign? That's correct. We're still on the left hand side of the equal sign. We did not transpose any of these terms to the right. So we do not change the sign in that sense. But we're going to move the plus 7 from the left of the equal to the right hand side of the equal. So it's now moved from plus to minus 7. And 2x minus 1x is actually x, and 10 minus 7 is actually 3. So we found x, which is 3. All right, let's see how we'll find the y value. So we need a little space up top here. Let's erase this. So what we're going to do, we're going to substitute x equal 3 in equation. Let's write that. Substitute x equal 3 in any one of these equations. You can use equation 1 or equation 2, or this third equation that we have found. Remember when we transpose the x and make y the subject, we got this equation. We can actually use that one as well, which is the easiest one to use since we already have y isolated. So we can actually put it in this one, but let's use the first equation. And so equation 1, let's call equation 1 up, which is x plus y equals 7. And we're going to put the x value of 3 there. So let's put 3 plus y equals 7. Means y is equal to 7. Transposing this plus 3 over as a minus 3. And so we have y equal 4. So we found the value of x and y. And we can check our values. Let's see. X is 3, y is 4, correct? So this is going to be 3 plus 4 equals 7. Let's use the other equation, see if it works for that one as well. 2 times x, or 2 times 3 is actually what? 6. This is in 2 times x value. X value is 3, so 2, 3, 6. 6 plus the y value of 4 gives us 10. Definitely correct. Alright, so we have this question that says, if p is equal to 2, and the product of p and q is equal to 8, that is p times q equals 8, then q is equal to what? Think about it. P times q give us 8. Now p is 2. 2 times what gives us 8? Must be 4. Since p, we're told p here is 2. This is in 2 multiplied by a number q. When you put them together, when you put two variables or two letters together like this in algebra, it means you're multiplying. So 2 times what quantity give us 8? Must be 4. Alright, so if you want to do it, let's write it down quickly. P times q equal 8. And p is 2, so 2 times q give us 8. And so we can actually solve this by dividing both sides by 2. 2 and 2 goes 1, so we're left with what? This implies that q, which we have here, is equal to 2 into 8 goes 4 times. That's our solution. (6.7) squared minus 0.3 squared is equal to which one of these? Now notice it says equal to, so it's not an approximation. What exact value? Now 6.7 is close to 7, but not 7 as yet. So we're going to take this as 7. Let's treat it as 7. I'm going to say that it's approximately equal to about 7 squared, which is going to be 49. So we treat this 6.7 as 7, and the 7 squared is 49. But we know it's a little less than 7. Alright? And we're going to subtract 0.3 squared. Now 3 squared is 9. And since we're multiplying 0.3 times 0.3, our answer should have 1 dp plus 1 dp. That's 2 decimal places. So we want to make the 9 have 2 decimal places. So how would we do that? So it's going to be 0.09. And if you notice, we have 2 dp now. So the 9, we start with the 9 and move 2 places inward. 1, 2. So that'd be 0.09. So it's 49 minus 0.09. So this is taking off 0.09. So it's definitely going to be less than 49. So this is out. This is too small in terms of 7.0. And 40.96 might be a little bit too small. So therefore the answer should be about 44.8. So what we're going to do, we're going to basically look at a different method. 6.7 squared, we can actually utilize something called a difference of two squares. So 6.7 squared minus 0.3 squared. Look at this as a squared minus b squared. Now this is called the difference of two squares. Difference because we are subtracting, finding the result, and so the result is called difference between two square numbers. Hence the term difference of two squares. Now, when we have the difference of two squares, we're going to get, in the factorized form, the sum of the roots multiplied by the difference of the roots. You could have the difference first, as in minus here and a plus here. But the order of multiplication doesn't matter. So it doesn't matter if you multiply a minus b by a plus b or a plus b by a minus b. So we can recognize that the a here is like the 6.7 that we're squaring, and the b is like the 0.3 that we're squaring, and so this is going to be 6.7 plus 0.3 and 6.7 minus 0.3. Now, of course, you can easily see that this is going to be what? 6.7 plus 0.3, you can see that it's going to be 7. And 0.3 off of 6.7, we can see that is 6.4. I mean, you can add this and see. All right, easily added. So 6.4 multiplied by 7. Let's look at it. 7 fours, that's 28. And 7 times 6 is 42, plus 2, 44. This answer has 1 dp. Well, this quantity has 1 dp. This has 0 dp as a decimal place, or places after the point. And so the sum of the decimal place that I should have in my answer is 1 dp. 1 dp. So therefore, I'm going to move the point one place inwards, and so my answer should be 44.8. If you want to stay on, and I could calculate the 6.7 plus 0.3, so you can see how I got that. 6.7 plus 0.3, 3 plus 7 is 10, and the 6 plus 1 here is 7. So 7.0, so we got a 7 here. So 6.7 minus 0.3, 7 minus 3, that's 4. 6 minus 0, that's 6. So we got a 6.4 here. All right.
The decimal equivalent of 3/8 is, which one of these is a decimal equivalent of 3/8? Well, one thing you want to remember is that 1/8 is equal to 0.125. Please remember this. It's very helpful. How so? Because if you know what 1/8 is, then finding 3/8 is very easy. So all you got to do, recognize that 0.125 is 1/8. If you add another 0.125, that's 2/8. If you add another one, that's 3/8. And adding these up, 5 plus 5 is 10 plus 5 is 15. 3 5 is 15. 2 plus 2 plus 2 is 6 plus 1 7. 1 plus 1 plus 1, that's 3. That's 0.375. Just remember that 1 divided by 8 is 0.125. Next method. So we found the answer, which is actually A. Now, what about another method that we could actually use? Well, let's do it the long way. How many times can we get 8 out of 3? Only 0 time. 8 cannot enter into 3. So we put 0. Now, we're going to put a 0 next to the 30 as well, so that 8 can be divided into 30. 8 into 30 goes how many times? Now, of course, if you know your 8 times table, you know that 8 times 3 gives us 24. 8 times 4 gives us 32. Now, 8 into 30 goes how many times? Well, we cannot get 8 fours out of 30. Since 8 fours is 32, we don't have enough to get 32 out of 30. And 32 is actually 8 fours. Can we get 24? Let's look at the next multiple of 8, that's 1 less than 8 fours. Let's get 8 threes, that is. Can we get 24 out of 30? Yes, we can get 24 out of 30. So we'll have a remainder of 6. Now, 24 is actually 8 threes, so we're going to put a 3 here. So 8 threes is actually 24. In other words, we can get 8 into 30 3 times, because 8 3 is 24, but we'll have a remainder of what? 6. We're going to put a 0 so that 8 can be divided into 60. Now we want to remember that 8 times 5 is 40. 8 times 6 is 48. 8 times what? 7 is 56. And 8 times 8 is 64. Now, how many 8s can we get out of 60? Can we get 64 out of 60? No, of course not. That's too much. Can we get 56 out of 60? Yes. And what is 56? 56 is actually 8 sevens. So we can get 8 sevens out of 60. In other words, we can get 56 out of 60. So 8 into 60 goes 7 times, since 8 7 is 56. And if we get 56 out of 60, we'll have 4 remaining. Put a remainder here. We're going to add a 0 so that 8 can be divided into 40. 8 into 40 goes exactly what? 5 times. And put a 5 here.
And that's it. We have no remainder. So that's our answer. 4x minus 3 multiplied by x plus 5. All right, so what we need to do here, we need to expand this bracket. We need to expand this bracket. So we're going to write back the 4x. And this is saying to expand the bracket, we multiply by the term immediately outside or preceding the bracket. So it's 3 times x, but just don't say 3 times x. We have to work with the sign before the 3. So it's negative 3 times x, negative 3 times 5. So what's negative 3 times x? That's negative 3x. And what's negative 3 times 5? That's going to be negative 15. And 4x minus 3x, that's x minus 15. So our answer is D. And now here we have this question. It says 7x minus 3y plus 2x minus y. So how do we do this? That's correct. We want to group the like terms, correct. So we're going to take the 7x and the positive 2x and group them. Notice that we do not have an equation. In other words, we don't have the left-hand side equal right-hand side. We do not have that. So this is an expression. This is an algebraic expression, meaning that when we move around the terms, we do not change the operations. So the 7x, we just write back the 7x. And the plus 2x, we just simply write plus 2x. We are not transposing because we don't have two sides. We only have one side in the expression itself. And we're going to take the minus 3y. So let's write that. So we have minus 3y. And we're going to also take the minus y, or minus 1y. Minus 1y. Let's put the 1 there, just for now. And so when we're adding two terms that are like terms, we look at the coefficients, and they're both positive, so we add and keep the sign. So we're going to add 7 and 2, give us 9x. And let's look at this. We're adding negative 3y to negative 1y. Even though you're saying minus 1y, we can treat this as a plus. In other words, we can say negative 3y plus negative 1y. Right? So these are the two terms that we're adding. Negative 3y and negative 1y. And the rule is when we add in two terms with the same sign, we add and keep the sign. The signs are the same. We have a negative, negative here. So what we're going to do, we're going to add the two numbers, two quantities in 3 and 1. That's give us 4. We're going to add them and keep the sign. And of course, we want to keep the variable 2. And so this is our solution. All right, so we have the question 3m squared n to the third power times 4mn squared is equal to which one of these? Well, look at it. When we multiply 3 by 4, what do we get? We're multiplying two terms, okay? So we have 3 times 4, and that gives us 12. And so definitely we know that these options are out. So we have two options to choose from. Okay, so we have 12 in this one and 12 in this one. What about m squared times m? M squared times m. Now here's the thing. This law of indices, if you have a quantity raised to a certain power, multiply by another quantity which is the same in number, raised to a different power, the rule is to keep the base in terms of a and add the powers m plus n. All right, and so the same thing goes with m squared. Let's look at what we have here. We have m squared times m, and m is really to the first power. So it's m squared multiplied by m to the first power. And if you think about it, if you want to expand this, m times m is m squared. Let's put back this times m, because we only have one power there, so it's just m. And if you look at it, we have m times m times m, which is what? M to the third power. So a faster way is simply to keep the base in m and add the powers 2 plus 1, and we get the same 3. So m to the third power, let's compare the m's. Well, this one has to the third power, this one has to the second power. We don't even have to do the last one, which is the n. And so we definitely know that this is our correct solution. And if you want to check the last one, let's look at the n's. N to the fifth. Well, sorry, let's go back up here. N to the third times n to the second. So we have what? N to the third multiplied by n to the second. Again, this can be written as n times n times n. Bring back the multiplication sign times n because we have n squared. And we can count it. How many n's we have multiplying? How many factors of n? 1, 2, 3, 4, 5. In other words, n to the fifth power. So this will give us n to the fifth power. And we can just look at it. If we add 3 to 2, we get 5. And so we have it right here. So even though we have n to the fifth and n to the fifth in both, the key was the m's. That makes a difference. Now, this question here is a bit tricky. A lot of person may just jump and say, okay, I'll look at A as my answer. Is that your choice? Well, A is not the solution. Let's see why. What we need to do, first of all, is to expand this to see, bring it to a familiar form. In fact, what we have here is really 6x divided by 3 minus 9 divided by 3. So let's write it that way first of all. 6x divided by 3 minus 9 divided by 3. And if you were working in the reverse, you'll see, okay, I have the same denominator in 3, and I subtract the numerators if you're working from here to here. So we're just reversing it. And we can actually simplify each fraction in itself. So we can say 3 into 3 goes once, and 3 into 6 goes 2 times. So what we have here now is 2x, since the 3 goes into 6 twice. Now let's do the other fraction. 3 into 3 goes once, and 3 into 9 goes 3 times. And as you can clearly see what we have 2x minus 3. And so that is our solution, 2x minus 3. And so C is our answer. We're given the question. It reads, if V is equal to U plus AT, then T is equal to. So we have the formula that we want to make T the subject. In other words, we want to isolate T. We want to have T equal instead of V equal. So how do we do that? Well, let's write the formula. V equals U plus AT. First thing we want to do is to get rid of what's affecting everything else. Now we recognize that U is being added to AT. So we can transpose the U since it's actually being added to everything else on this side. And so we're going to have V minus U equal AT. Why we didn't move the A first? Because A is connected to T by multiplication. A is not multiplying U, only T. All right, so what's the next step? The next step is to divide by A, because A is connected to T by multiplication. So to remove A, we divide by A. And we do that to both sides. And so A is cancelled, and so we're left with T equal, we have T here, equal to V minus U over A. V minus U over A. In this problem, we are subtracting two fractions. Whenever you're subtracting two fractions, you want to ensure that you have the same denominator. Why? Because that's the only way you can actually operate on the numerators. Looking at the options, we can clearly see that 12xy will be the LCM of 4x and 6y because they all have 12xy. In case you didn't know this, let's look at how they got the 12xy. The LCM of the coefficients, 4 and 6, is 12 because 12 is the lowest number that 6 and 4 can enter without a remainder. The multiples of 6 are 6, 12, 18. Just keep adding 6, 24, and so forth. The multiples of 4 are 4, 8, 12, 16, 20, 24, and so forth. Now, we have common multiples here between 6 and 4. We see that 24 is a common multiple to both. 12 is also a common multiple to both, and we have many more. But the lowest one is actually 12. We call this the lowest common multiple of 6 and 4. And so the LCM of 6 and 4 of the coefficients of the terms is 12. And since you want to be able to divide the LCM by each denominator, you want to ensure that you have the variable x involved and the variable y involved. So you'll be able to cancel out the denominator. when you divide 12xy by 4x, and when you divide 12xy by 6y. But remember, you don't go finding the LCM since they're all the same in each option. That will take away from the time that you have remaining. So what you'll do, you'll take the LCM of 12xy and divide by the first denominator. And so 12xy divided by 4x will give us, let's cancel the x's. X into x goes once. Now 4 into 4 goes once, and 4 into 12 3 times. Now we have remaining 3 times y, which is 3y. We take the 3y and we multiply it by the corresponding numerator. So 3y times 3 will give us 9y. Already it looks like the answer is going to be A. Now let's look at dividing the LCM 12xy by 6y. 12xy divided by 6y, y into y goes once and y into y goes once. 6 into 6 goes once and 6 into 12 goes twice, or 2 times. 2 times x leaves us with 2x. We're going to multiply that result that we got by 2. So 2x times 2 will give us 4x. And so 9y minus 4x will be the solution in the numerator. We cannot take 4x from 9y since they are unlike terms. Therefore, so our solution will be 9y minus 4x over 12xy. For this question, remember we cannot use calculators. So we want an easy way to be able to divide these numbers we're about to get. So item 4 refers to the following diagram here. The fraction of the circle which has been shaded is, and we have the options. Now, as we can see, we have this sector. We have 2 radii and an arc, and the region bounded between it, the shaded region that we have here between 2 radii and an arc. And so we call it sector. The angle for the sector, which we do not know, when added to the external angle of 285 will create a what? A circle. And a circle has 360 degrees. So if we know the external angle of 285, we just need this piece here, this angle here, I should say, not the piece, but angle. If we know this angle here, when added to 285, we should get a full complete circle, and that will be 360 degrees. So if we should take the 285 from the 360, we'll get the remaining amount, correct? That's good. 5 from 0 we can't, so we're going to borrow 1 from the next digit next to the 0, which is borrow 1 from the 6, leaving 5. The 1 we borrow, put it next to the 0. I'm going to treat this as 10 now. 5 from 10 will give us 5. Now 8 from 5 we can't, so we're going to borrow 1, leave 2, put the 1 next to the 5. So we have 15 here, treat it as 15. 8 from 15 give us 7. We could have said 35 minus 28 give us 7. All right, nevertheless, this is 75 degrees, the sector angle. When added to the external angle, we get 360. External plus the internal creates a circle, basically. And so we have 360 degrees together. But the sector angle, the shaded region, is a sector. The shaded region represents 75 out of a total of 360 degrees. Now, if we should break this down into a simplified fraction, we want a number that can enter 75 and 360. Think about 15. 15 can actually enter 75. Think about 15. So we have 15 plus 15 give us 30. That's 15 times 2. 15 times 3 is 45. If you think about adding 15 to 30, it's easily 45. And if we add 15 to 45, we will get 60. Think about doubling. Think about doubling the 30. 15 times 2, which is 15 times 4, which actually is 60. And if we add 15 to this, we should get easily 75. So we should actually know this by heart. 15 times 2 is 30, 15 3 is 45, 15 times 4 is 60, 15 times 5 is 75. This will be very helpful in multiple choice questions. All right, now, so we know that when we divide the 75 by 15, we actually get 5. 1, 2, 3, 4, 5. 15 goes in 75 5 times. What about 360 though? Let's look at 360. All right, we can do it 2 ways, but we want an easy way to look at it. But let's look at it from this standpoint. Then we're going to look at another way. 360 degrees divided by 15. Okay, let's look at 360. Let's break it up into comfortable parts in 300 plus 60. 360 is same as 300 plus 60. Agree? Okay, great. Now, what if we want to divide this term? Think of this as an equation. We want to divide 360 by 15. That's our goal, right? We divide 75 over here. Divide 75 by 15. Now we're trying to divide 360 by 15 to see what we'll get. So 360 divided by 15. If we divide one term by 15, we need to divide the other terms by 15 as well. Now, how many times 15 goes into 60? Look at it over here. 1, 2, 3, 4. So 15 goes into 60 4 times. Now 15 goes into 300 how many times? That should be easy. 15 into 15 goes once, and 15 into 30 goes 2 times. And so we have the 0 there, so that's 20 actually. We can actually just draw a line through that. So 15 goes into 300 20 times. So 20 plus 4 is actually 24. In other words, 360 divided by 15 is 24. And so our answer is 15 divided by 24. Now, another way to do this is dividing the 360. Let's look at it. 360 divided by 15. So we're going to say 15 into 3. We can. 15 into 36 goes 2 times because 15 times 2 is 30. So we're going to subtract. Now, let's see. 0 from 6 give us 6, and 3 from 3 that gives us 0. So we just put a dot there. We're going to bring down this 0. Now we're going to say 15 into 60 goes how many times? 1, 2, 3, 4 goes 4 times. And 4 times 15 give us 60. And we subtract 60 from 60. We get zeros there. So the answer is 24. So 15 goes into 360 24 times. And so this is our solution. Now, if you want to break down 75 divided by 360, and you're comfortable using small numbers, you could divide by 5, which will give you 15 over 72. But you'd have to show that 5 goes into 360 72 times. Then if they divide 15 by 72, now 3 can actually enter 15 5 times, and 3 can enter 72 24 times. So that's another way we can actually do it as well. Hope this was helpful. All right, so this question reads, if P star Q is equal to P squared minus PQ, then 5 star 2 is equal to what? Now, this is referred to as binary operation. Binary operations. And basically, it seems like you're just adding 2 numbers, subtracting 2 numbers. You know, the plus sign gives an instruction that you must add the first number to the second number, right? This is what the symbol means. In binary, we use different symbols. For instance, we may use this, the dot in it. We may use the star, like we're seeing right here. So we have different symbols, and this is a popular one. Now, the instruction is saying if P star Q is equal to this instruction right here. So we see in the instruction right here. This is the instruction. This is what we actually do to the 2 numbers that we have. All right. Now P is the first number before the star, and Q is the number appearing after the star. So it's basically the number that we're seeing here, 5 appearing before the star, is now taking the place of P. And the 2 that we have here, right here, is taking the place of Q because it comes after the star. All right, so simple as that. So let's write it out. We have P star Q being equal to P squared minus PQ. And so what we need to do is just basically substitute. So what we're going to do, we're going to put in place of the P, we have 5. In place of the Q, we have 2. And we just do the same thing. Wherever we have P, we put 5. And wherever we have the Q, we put the 2. And work that out. 5 squared is 25 minus 10, and that gives us 15. And so our solution is correct. A. So this question reads, if A is equal to the square root of 2P divided by M, then P is equal to which one of these? Well, the first thing I'll do, let me just write back the problem. And then I want to identify what operation is affecting all the quantities or terms on the side where P is located. So P is located on which side of the equation? So here we have the equation. We know that the left-hand side is equal to the right-hand side of the equation. So here we have the equal sign, and here we have the left-hand side. and here we have the right hand side. So we're working with the right hand side since that's where we want to isolate P. Okay, so we want to isolate the P. To isolate P, we see what's affecting everything on this side. So if you look at it, the square root is affecting this quantity here, which is 2p over m. So we want to get rid of the square root first. Look to see what's affecting everything else. Now, how do you get rid of square root? Now, square root, you get rid of square root. The reverse of square root is the square, right? Square is the opposite of square root. Think about square root, yes. So we're going to square the square root to get rid of it. And I do that to both sides. So if I square everything on that side, I will have to square everything on this side as well. So I'm squaring this side as well as this side. Now what happens here is that a gets squared, so we have a squared. And the square root is cancelled out by the square. So this square cancels out with the square root, leaving me with what? With just the 2p over m. Now I need to see what's affecting everything else on this side. What's affecting everything else on this side? What operation? We have division and we also have multiplication. The m is dividing 2p and 2 is multiplying p. So since 2 is only multiplying p, it's not multiplying m, I'll get rid of the m first since m is dividing both 2 and p. So 2p divided by m. So I'll get rid of the m first. Again, we're getting rid of what's affecting everything else. Now we get rid of m by multiplying by m. Now notice that the m is in the division position, so we multiply by m since m now is in the numerator position here. And what we do to one side, we want to do to the other side as well, correct? So we're going to likewise multiply this side by m. And this gives us a squared m or ma squared. Doesn't matter which one. Let's put it in alphabetical order though. And so m into m goes once, and m into m goes once. So that's how we cancel the m. Since we're divided by m, we multiply by m to cancel, and we do it to both sides. So tidying this up, we have a squared m, or m a squared, on the left hand side. And on the right hand side, we'll have 2p. 2p divided by 1 is still 2p, multiplied by 1 is still 2p. Now, how do we get rid of the 2? Notice that the 2 is affecting everything else on this side now. So we get rid of the 2, since it's multiplying by 2, by p. We're going to get rid of the 2 by division. So we divide both sides by 2. 2 into 2 goes once, 2 into 2 goes once. And that leaves us with what? P is equal to a squared m over 2. And that looks like the choice that we have right here. All right, so P is equal to a squared m divided by 2. Which of the following numbers is a prime number? So the first thing we want to keep in mind is that a prime number is a number that has two distinct factors. So if we think about the first set of prime numbers, like for instance 1, it's not a prime number. Why? Because 1 only has one factor in itself. Even if you want to say it's 1 in itself and 1, it's still 1, only one factor. We want two distinct factors. So distinct means two different factors. All right, so let's look at the next number 2. What about the number 2? Is that a prime number? How many factors 2 has? Well, 2 has two factors. 1 times 2 gives us 2. So therefore, 1 and 2 are the only two factors of 2. And we have two distinct factors. So 2 is a prime number. What about 3? Same thing goes for 3. 1 times 3 gives us 3. And only 1 times 3 as whole numbers will give us 3. So yes, 1 and 3 are the factors of 3. And so we say 3 is a prime number. What about 4? 4, no. Because why 4 isn't a prime number? Well, if you think about 4, 1 times 4 give us 4. 2 times 2 give us 4. So when you think about it, we have 1, 2, and 4 are factors of 4. So we have more than 2 factors of 4. So 4 is a composite number. So this is not a prime number. All right, so you understand what prime numbers are. So let's look at this. What is the square root of 1? Well, 1 times 1 gives us 1. So therefore, the square root of 1 is 1. So the A is really 1. What about B? Square root of 4. What number times itself gives us 4? 2 times 2 gives us 4. So square root of 4 is the same thing as the number 2. All right, so which of the following numbers is a prime number? If you look at this, 1 is not a prime number. Is 2 a prime number? Definitely. Which is the same thing as the square root of 4. For the square root of 4 is the same thing as 2.
Alright, so what we're going to do for this question, it says if f of x equal x plus 1 and g of x equal 2x minus 3, then the value of f of g of 5 is one of these options. Let's look at one particular method we could actually use, which is to find f of g of x. Form an expression for f of g of x. Once we form an expression for f of g of x, we can then replace the x with 5. In fact, we'll be finding f of g of 5 in that instance. Now, the first function we're seeing is f. So we're going to write the f function, which has been given to us, which is f of x being equal to x plus 1. Then we're going to look at the second function. So this is the first function. We're going to enter the second function into it, which is the g of x function. So where we have x, we're going to be able to input the other function into it, the g function into it. So where I have x here, I'm going to replace x with the g function. Now the g function, look at it right here, g of x is equal to 2x minus 3. So I'm going to let 2x minus 3 represent g of x. In fact, g of x is equal to 2x minus 3. So 2x minus 3, I'm going to replace x with it, 2x minus 3. So in fact, what am I really saying here is f of g, because 2x minus 3 is g of x. So f of g of x is equal to, now I replace x with 2x minus 3 on the left hand side of the equation here. So this x, replace it as well with 2x minus 3. So we're basically replacing x on both sides. What is the right hand side that I'm more interested in? So let's simplify over here, If we want to remove bracket, there should be a number in front, and so we're going to put a 1 there. So 1 times 2x is 2x, and 1 times negative 3 is negative 3. So we have removed the bracket. We can put back the plus 1, and this will equal to 2x, and the negative 3 plus 1, that's be negative 2. So we can clearly see that f of, now remember the 2x minus 3 is really what? G of x. So this is really f of g of x is equal to 2x minus 3. Now remember, we're asked to find f of g of 5. So I can write this as f of g, and where I have x, I put the 5 there. And so I'm going to replace x with 5. So wherever I have x, I'm going to put 5. So this is 2 times, and we're working with this over here. So it's 2 times the x value, which is 5, minus 2. Now 2 5s is 10, and 10 minus 2 gives us 8. Alright, so that's 8. So our answer is 8. So that's one method. Okay, what's the other method? The other method in finding what f of g of 5 is to work out what we're seeing here, closest to the 5 is g, so we can work out this. We can work out this, what g of 5 is. And whatever value g of 5 is, we put it in the f function, which is this function here. So let's work out g of 5. So g of 5, let's write g of 5. How are we going to write g of 5? Well, we need an expression first before we can get the value. So g of 5 is 2x minus 3 according to what's been given to us here. Right? So g of x is 2x minus 3. And since we want to find g of 5, we will basically take the 5 and place it where x is. So basically substituting x with 5. This gives us 2 5s, 10. 10 minus 3 is 7. So g of 5 is 7. So again, we're going to replace this g of 5 now with what? With 7. So in fact, we're finding f of 7. Remember, 7 is really g of 5. Now, which function are we working with here where we enter 7 in the f function? Of course, the f function. So we're basically going to replace the x with 7. Instead of saying f of x, we're saying f of 7. So f of x is equal to x plus 1. Remember, So in place of the x, we put 7 plus 1, and 7 plus 1 is 8. Again, we're working with this. F of x equals x plus 1. And so since we're finding f of 7, it's 7 plus 1, which is 8. That's what we did here. Again, so that's the answer. All right, for this question, what you really want to do, you want to basically substitute these x and y values into the original equations. All right, so the question reads, what are the solutions for the pair of simultaneous equations? We have equation 1, we have equation 2. So let's try them. That's basically how you do this. So we're going to take equation 1, for instance. We're going to try, let's try A. So it's going to be 3 times the x value, which of 2, plus the y value of 1. And if you try this in your head, 3, 2, 6 plus 1, you get 18? No, we do not get 18. In fact, 6 plus 1 is actually 7. And 7 is not equal to 18. So you can do this in your head. So you basically go like, all right, so 3 times 2. I'm going to put a 2 here, for instance. So you see 3 times 2 give me 6, and 6 plus the y value of 1. Will that give me 18? No. So you know this is definitely out. So A is definitely out. What if you try B? If you should try B. And so you'd be 3 times negative 2. So you're going to basically, let's try these options. All right, so x equal negative 2. So 3 times negative 2 plus the y value of negative 1. Will that give me 18? Look at these numbers. Definitely not. 3, 2, 6 would be negative 6. And this would be, adding the negative is minus 1. So definitely you cannot get 18 with this. This definitely is out as well. So when you're doing the multiple choice questions, you don't want to spend forever trying to do it the long way. Just want to use the smartest options. All right, so let's try D and see if D works. Of course, I would probably try C and then D, but let's use D for instance here. See if that works. All right, and so we're gonna have 3x. Okay, so we have the first equation. Let's put in x equal 3. Let's see if that works. So we have 3 times x, which is 3, plus y times 5 is 5 there. 3 3 is 9, and 9 plus 5 is actually what? What's 9 plus 5? 14. So we definitely did not get 18. So we definitely know that this is 1 is out. So the option must be D. And if we look at D now, let's try D. You don't need to try it once you x, you basically x out the rest, but let's see. 3 times the x value of 5 plus the y value of 3 gives us what? 18. Let's see. 3 5 15 plus 3 definitely give us 18. We try the second equation, see if it works. 2 times x value minus y, 2 times 5 minus y value of 3. 2 5 is 10 minus 3, and that definitely gives us 7. And so, yes, it does give us 7, and it also gave us 18 when we try it down here. So the x equal 5 and y is equal 3 actually works. All right, so we have this question that says, if p is equal to 2, and the product of p and q is equal to 8, that is, p times q equals 8, then q is equal to what? Think about it. P times q give us 8. Now, p is 2. 2 times what gives us 8? Must be 4. Since p, we're told p here is 2. This is saying 2 multiplied by a number q. When you put them together, when you put two variables or two letters together like this in algebra, it means you're multiplying. So 2 times what quantity give us 8? Must be 4. All right, so if you want to do it, let's write it down quickly. P times q equal 8, and p is 2, so 2 times q give us 8. And so we can actually solve this by dividing both sides by 2. 2 into 2 goes 1, so we're left with what? This implies that q, which we have here, is equal to 2 into 8 goes 4 times. That's our solution. The square root of 490 is approximately which one of these? Well, we need to look at what these numbers are saying here to us. So we have 2.2 times 10, which we know 10 is 10 to the first power. And we move one place to the right. Since it's a positive power of 10, we move to the right. And so this is actually 22. So A is the same thing as 22. What about B? We move one place to the right as well. So that's 25. What about C? So it's times 10 to the first power, move one place to the right. So this is 70. And D, since it's a negative power multiplying by, we move to the left instead. So that's actually 1.45. Now, which one of these numbers, when we square them, we get 490? Such that when we square 490, we get one of these, or close to one of these, I should say. All right, let's start with C. 70 squared, which means 70 times 70, is equal to 49 with 2 zeros at the end. So let's 7 times 7 is 49 and put the zeros at the end. So the square root of 4,900 or 4,900 is 70. So definitely square root of 490 would definitely not be 70. So that's out. Now you can't say it's going to be 7. Alright? Because 7 7 is 49. So that's still off. What about D? 1.45. Even if we carry 1.45 up to, let's say, 2, we know 2 times 2, or 2 squared is 4. So the square root of 4 is 2. That's definitely too little bit. And we know that 25 squared, we should know that by heart, is 625. Right? Always know this, that square root of 25 is 625. That is way too much. So the only option we have remaining is A, 22 squared. Let's double check that, shall we? And so we have 22 squared, which means 22 times 22. 2 2s, that give us 4. 2 2s, that give us 4. 2 2s, then we're in the 10th place. 2 2s give 4, so we're going to start in the 10th place. And 2 2s, 4. That's going to be 4, 8, 4. 484. And so we don't have any decimal places here in these numbers, so our answer stays as 484. So the square root of 484 is 22. So the square root of a number that's very close to 484, just 6 more added on to 484 give us 490, will be approximately 22. So A is our answer.